Have you ever built a PC before? If you have, you know that it's not as difficult as it might seem. If you haven't, I would thoroughly recommend you go out and try it yourself. When you build a PC, all you're really doing is creating a very small list of some very expensive parts, ordering those parts, wiring them together, and you can accomplish a build in an afternoon. It's actually very, very easy. But now imagine you were tasked with the problem of building a computer, but you don't get to buy any of the parts. You have to build that computer from the ground up. You don't get a CPU, you don't get a motherboard or power supply. You have to design a computer that works just as well as your current one and may handle incredibly large data sets. Of course, there are people with this job, and they're called hardware design engineers. They tend to be paid relatively well, about $100,000 a year. Since most large technology companies either appear on the West Coast or over in Asia, the center of the job market are in these two locations. If you want to work for, say, Apple or Intel, you're probably either going to be working in Houston, Texas, or in California, or sometimes up at the Intel campus in Oregon. If you want to work in the Asian markets, you're probably going to be working for Samsung, considering they're one of the largest employers of hardware engineers in Asia, making them the highest employer of hardware engineers in the world. So those are the two locations you're going to see where you're going to find the most work. But now, what is a hardware engineer? I've kind of given a general overview, and here I want to jump into some specifics. A hardware engineer is a person who has to have a wide range of skills, with a specialization in either electrical engineering or computer sciences. I want to read off a job description for a senior hardware engineer from L3TRL Technology, a company dedicated to cybersecurity and warfare. Here we can see a wide range of responsibilities, from documentation of design specifications to realization of complex system requirements to collaboration with other team members, development of appropriate test hardware and procedures, managing component obsolescence throughout the hardware's life cycle, and, very importantly, flexibility. So a hardware engineer isn't just responsible for designing hardware. They're responsible for their team working well together to design this hardware, since after all it is going to be enormously complex, and one person probably isn't going to be able to design it all to themselves. They also have to be able to communicate with their clients and with the higher-ups. They need to be able to tell people who aren't in their field what they're doing. They also need to be able to test their hardware, so they need coding. They also have the responsibility of, after their hardware's been released out into the world, is their hardware doing okay? Is it serving everyone's needs? If it's not, can they fix it? Can they release something to help make it work, or do they have to scrap it? And when the product is finally discontinued from whatever company they happen to work at, they have to be ready for that obsolescence. So now, what does it take to become one of these hardware engineers? I want to examine what employers are looking for in a bachelor's degree, but also what they're looking for in post-bachelor's education. If you want to be a hardware engineer, there are kind of two different degrees you're going to want to consider. About 68% of the people working in the field held at least a bachelor's degree, so we can see that that's a pretty good indication that you definitely need a bachelor's degree in something. Of those with bachelor's degrees, the top two most popular were computer engineering and computer sciences. These degrees both have emphasis in two key aspects of hardware engineering. You have to understand software design and you have to understand logic design. As I mentioned, a hardware engineer needs to be able to test their hardware, so they need to be able to know how to code. But they also need to understand the fundamentals of logic and how logic gates can be arranged, because essentially computers are just very complex circuits of logic gates built up with thousands and thousands of operations happening at any particular moment. So you have to have a very good understanding of logic design. Now, there are places you can go to get a specific degree in hardware engineering, though they are quite rare. One example, actually pretty close to home, is up at UW, where they offer a BS/MS program, where you spend an extra year on top of your bachelor's degree learning about hardware design specifically. You come out with a degree specifically as a major in hardware. There are a lot of universities that will offer courses in hardware design, but most colleges don't offer a specific hardware design focus or major. Colleges would prefer that you got that training perhaps maybe on the job or in future higher education, because it tends not to be offered unless it's under the title of computer sciences or electrical engineering. However, sometimes getting a degree isn't enough. Clive Maxfield is a hardware engineer working in the field today, as well as an editor-in-chief of two internet-based publications which deal with hardware and system design. He was asked by a young startup engineer whether a bachelor's degree was enough, and he points out that he too participated in logic design and programming in college, but, quote, there is a big gap between the classroom and the real world. He began his career in a mentor program where younger, less experienced engineers were assigned more experienced engineers for training, though, in a 2011 article entitled, "Where Have All the Mentors Gone?" he laments that the culture of hardware engineering has shifted away from this approach. Of course, a master's degree is always going to improve your chances. You're specifically going to want to look for a master's degree in business administration because of the emphasis on teamwork, leadership, and communication. In a master's business administration, you can also focus on one particular field of business administration, in this case, hardware design. In addition, hardware engineers need to be all-around good learners. They have to be constantly on top of whatever's going on in the industry in that particular period of time. Now I want to look at my own education at Evergreen, and I want to compare it to what I see as the job requirements of a hardware engineer. At Evergreen, I've spent about 3/4 learning Java programming, about 3/4 learning Haskell programming. In at least one other class per quarter, we used programming, usually Java, as a tool to exemplify concepts we were learning about in class. I've taken maybe 3 classes which specifically examine hardware functions. The first was a class in Logisim. Logisim is a program where you can plant logic gates and connect them via circuits. It's a really useful way of seeing how computers are built, and we built a lot of models of computers in Logisim. This was probably the most helpful for me when visualizing hardware. Next, we studied Arduinos, and we worked to create our own individual projects using Arduinos, some breadboards, some CPUs, some lights, the whole deal. However, with Arduinos, so much of it was stuck in coding that the hardware design itself was actually fairly minimal, or at least in the case of myself. Finally, in computability, we learned about formal languages, which is all about logic design. But formal languages isn't really about the application of logic design. It's more just about the theories of logic design and language design. So I can't exactly say that I feel confident in hardware design from the education I've received. Certainly, I've got a lot of experience in programming, which is good and something that's going to be very useful to me. But I would need to take more classes specifically invested in hardware design to truly feel confident in the field. In my research on this particular topic, I noticed that hardware engineers were using skills and intelligence that just really amazes me. For example, CPUs used to use aluminum in their circuit boards because aluminum conducts electricity pretty quickly, and it's a good material to use. But it also has a real low melting point, and this was a huge problem. If you were running an especially strenuous program, what would happen if the strenuous program melted the circuit? Suddenly you've ruined a CPU, you have to take your entire computer apart, you have to reorient, whatever. So, some hardware engineer came up with the idea of using silicon instead. Now, silicon doesn't conduct electricity as quickly, but it is very, very durable. We now construct CPUs largely using silicon because of this. It's just so fascinating to me because it's not a field that we normally associate with hardware or engineering or computer sciences. What is this chemistry we're getting into? It's sort of miraculous that a hardware engineer even thought of it. I think this just goes to show that a good hardware engineer will always want to be a learner, and a good hardware engineer is going to want to learn about anything under the sun that might even in some tangential way help them. Hardware design does certainly feel like a field I could see myself in, although not with my current education. To truly feel successful here, I would need a lot more education, hopefully a mentor. I know that Clive Maxfield is pessimistic about it, but I'm actually kind of hopeful for the hardware design field. With the advent of the internet, so much of the information that was previously only restricted to senior hardware engineers is now open to the public. I hope that the internet and mentors provide future generations of hardware designers the skills they need to design the hardware of the future. Thank you for your time.